Hi there, this is part of the lesson 2 on variation calculations and graphs from the evolution topic in module 4 of A-level biology. I've already done a video on standard deviation and a different video on the student's t-test. So if you're looking for those, please have a look at those videos. This video is going to be about correlations and more specifically about the use of Spearman's rank correlation coefficient. So let's start at the beginning. What is a correlation? A correlation is simply a relationship between two sets of data. Often in science, we will plot graphs that have two axes, so an x-axis and a y-axis. And that's what we're talking about when we say our two sets of data. We're plotting two things against each other. There can be positive and negative correlations. A positive correlation will have a line with a slope that's going up. So this is a positive, because it's going up. And it would be strong in this case because the data points are all on or very close to the line. A negative correlation would have a slope going down. And in this case, we can draw a weak correlation because the data points are further off the line. We'll put one on the line there. And we will have a weaker correlation there. They're still reasonably close, so it wouldn't be a terrible graph. If you wanted to see what no correlation would look like, that simply means that as we increase the value of x, there's no appreciable change in y. So for example, your data set might look like this. So as I change one thing, the other doesn't change, and my line of best fit in this case might look something like that. So as I'm increasing the value of x, the value of y doesn't increase, so we say there's no correlation between those two sets of data. We are going to be using Spearman's rank correlation coefficient. The symbol for that is R subscript S, and it helps to show you the strength of a correlation, whether or not it's positive, whether or not it's negative. So if you have a score of +1 for RS, then that means it's perfectly positive. And if you have a score of -1, it is perfectly negative. So if you have a value for RS above 0, that's going to be a positive correlation. Below 0, so a negative number, that's going to be a negative correlation. And the closer those values are to either +1 or -1, the stronger they're going to be. You can also do a statistical test using the RS value to look for whether or not the results are statistically significant, and we'll have a look at how to do that in a minute. Let's have a look at the equation to begin with. RS is equal to 1 take away 6 times the sum of the difference in rank squared divided by the number of pairs take away 1. So what do we mean here? This, as we saw for the student's t-test, is the sum of symbol. This letter here is going to be the difference in ranks, and we'll look at what that means with an example in a second. N is the number of pairs. You need to remember that it's pairs. This is one of the common mistakes that people make. They count up all of the values. It's actually the pairs of values. Same for that N. And then the bit that people always seem to forget, bizarrely, is this bit here. And if you forget that, then you're going to end up with a really small number for a strong correlation. So important not to forget that. In terms of the steps for Spearman's rank correlation coefficient, the first thing you need to do is rank each variable, and I'll show you what that looks like in a second. You need to remember that the smallest value gets a rank of 1, the second smallest gets a rank of 2. If there are identical values, you're going to use an average rank, and we've got identical values in our example, so you'll see what that looks like in a second. You're going to calculate the difference in ranks for the two variables. So if you had rank 1 and 1, you do 1 take away 1 and 0. You're going to square all of them, then sum all of those up together, and that gets you to that bit there. Multiply that by 6, and then divide by the number of pairs, multiply by the number of pairs squared, take away 1. When you're checking for statistical significance, you need to write out your null hypothesis, which is that there's no correlation between the two factors. You are going to use the Spearman's rank table, where n is the number of pairs, not of samples. You are going to use p equals 0.05, just like the student's t-test, unless you're told otherwise. You're going to find the critical value and then compare that against your RS. Okay, this will make a lot more sense, hopefully, once we go through an example together. And we're going to investigate some completely made-up results of the relationship between the height and mass of men. So we have these variables here, and if we count them up together, we have 1, 2, 3, 4, 5, 6, 7 pairs. So we know right off the bat that n is going to be 7. Don't say n is equal to 14, that's going to get you into trouble. So n is the number of pairs. First thing we're going to do is rank the variables. So to start with, we're going to ignore the mass completely and just focus on the height. And we're going to rank these from smallest to largest. So my smallest one is 1.4, so that will have a height rank of 1, then 1.5, and then I run into two that are exactly the same. I've got 1.7 and 1.7. So these are going to be my 3 and 4 ranks. I'm going to take the average of that for both of them, so it's going to be 3.5 and 3.5. I've already used 4, so now I have to go to 5, 6, and 7. Some of you might be asking, why didn't you do 4? I did. One of these 1.7s is 3, the other one is 4, so the following number is 5. We do the same for the second variable, in this case the mass. Now I often find it difficult to concentrate on that column, so if it helps you, you can just cover up the other column with a piece of paper or by scribbling it over like I just did there. So again, let's have a look, and we'll do this one in a different color. So 69 is going to be number 1, 73 is going to be number 2, then we have 83, 85, 87, 91, which will be 6, and then 92, which will be 7. Okay. Okay, as you can see, I've just added a few columns onto my table here, rank difference and then the difference squared. So to do rank difference, we're just going to take the first value, so the first variable rank, and then take away the second variable rank. So here I have 2 take away 2 is 0, 1 take away 1 is 0, 6 take away 7 is minus 1, 3.5 take away 3 is 0.5. Just had a massive helicopter flying overhead. Apologies if that got picked up. 3.5 take away 5 is negative 1.5. 5 take away 4 is 1. 7 take away 6 is 1. Then we are simply going to square those values. So 0, 0, 1, 0.25, 2.25, 1, 1. The last step to do the numerator, so the top of our division there, is to add all of those together. So we can say the sum of d squared is equal to, we have 0 plus 0 plus 1 plus 0.25 plus 2.25 plus 1 plus 1 is 5.5. So we've calculated all of our values. Now we just need to plug them in. Let's remind ourselves of what they were. N was 7 pairs, and d squared was 5.5. So RS is going to be equal to 1 take away 6 times 5.5 divided by 7 times 7 squared take away 1, which is going to be equal to 1 take away 33 divided by 7 times 48, which is going to be equal to 0.90178574143. Now, if you got the value as your answer, 0.09821428571, that's because, like I said, you forgot to do one take away your answer. Okay? So our RS value is essentially 0.9. We said that plus 1 was perfectly positive, so we can say that this is a very strong positive correlation. We can't stop there though. We have to do our statistical test to see whether or not it is significant. To do that test, we're going to use a table similar but not the same as the one that we used for the student's t-test. We already know that n is equal to 7. Remember, n is equal to the number of pairs, not the total number of data points, but the number of pairs of data points, which was 7. We're going to use p is equal to 0.05. That should always be our default unless the question tells us to use a different column, so we know which column we're going to take, and we know that our RS value is 0.9018. Now you'll notice that there is one-tailed and two-tailed tests in this example. You do not need to worry about that. That doesn't come up on A-level biology. We know that our correlation is going to be positive, so we're only looking on one side. So we're going to go with a one-tailed test and ignore the two-tailed test. So we look for 0.05 and 7, and we see that our critical value is 0.6786. So our RS value is bigger than our critical value, so the results are statistically significant. We reject the null hypothesis. And that is how you do Spearman's rank correlation coefficient. I've put a question on the worksheet for you where you have to calculate this and then do your statistical test. Just follow the examples. Remember to do one take away the equation, and also remember that your n is going to be pairs of data, not number of data points. Thank you. We'll talk to you soon. Bye-bye.